Alright, so now a little bit more about power functions. So power functions. Alright, so for this, I'm going to show you a couple different cases. So as the limit as x goes to infinity of x to the n power, that's going to be equal to infinity to the n, okay, which is equal to positive infinity. And similarly, but on the opposite side, we have limit as x goes to negative infinity of the same thing, so x to the n. And then, so here we kind of have two different cases that go on. So basically, so what does this equal? Equals what? So if n is even, then that means that we get some negative value squared or to the fourth, to the sixth, etc. So if it's even, then we get a positive infinity out, okay? So then this limit equals, when n is even, we get a positive infinity, but if n is odd, then we'll have some negative value raised to the first, third, fifth, seventh power, etc., etc. So we would get that negative sign would be there, okay? Okay, so those are the two different cases that could happen to this limit here. Alright, so if n is even, you get a positive infinity. If n is odd, you get a negative infinity. Alright, so now for the last case that we'll look at for power functions is what if we have limit as x goes to infinity of 1 over x to the n. Okay, so this is actually going to turn out to be the same thing as, it's going to be equal to the limit as x goes to negative infinity of the same thing, so 1 over this x to the n, okay? And that's because if you plug in either of these, 1 over infinity to the n or 1 over negative infinity to the n, what we're going to get is like an infinity something, some huge number on the bottom, okay? Which is also the same as that, some huge number, so the 1 is going to look super small and insignificant. So it's almost going to be like a 0 in comparison to the tremendously large number on the bottom. So this limit, both of these limits here, so the ones right here, both of those are going to go to 0, or both of those are going to equal 0. Okay? Alright, so now let's do an example of when we show that basic limit laws, this is important, so basic limit laws that we've learned before, like the sum law, the constant multiple law, the product law, and the quotient law. So basic limit laws still apply, even when we're calculating limits as x is going to some kind of infinite value, so either positive or negative infinity. That was a really bad line, so let me redraw that. Okay. So let's do an example of this. We'll do limit as x goes to plus or minus, plus and minus, infinity of 12x to the third minus 2x, and this is going to be over 3x to the fourth plus 4x to the third and minus a 7. Okay, so if we try to analyze this now, if we try to plug that in directly, what we'll get is a 12 times infinity to the third minus 2 times infinity over 3 times infinity to the fourth plus 4 times infinity to the third plus or minus a 7. So what we get is some kind of infinity over infinity, which we'll recognize as an indeterminate value, indeterminate form, right? So that means we have to change something in our f of x, in our formula here, to make it a little bit more workable and actually get a non-indeterminate answer. Okay, so what can we do? We have limit as x goes to plus or minus infinity. What I'm going to do, so I'll rewrite this, so we have a 12x to the third minus 2x over a 3x to the fourth plus 4x to the third minus 7. Okay, so what I'm going to do is actually divide on both sides by an x to the fourth, because what I want to do is basically take this out of the denominator here. So see this highest power, the x to the fourth? I kind of want to cancel that out and just remove the variable from this term. So we're just left with a 3 here. So what I'm going to do is 1 over x to the 4th. Okay, so that'll cancel out with that if we multiply straight across, and 1 over x to the 4th. So I add this thing in here, which is like multiplying by 1, in order to change the form of our f of x. Okay, so let's see what happens. So we have limit as x goes to plus or minus infinity. Okay, so on top, what we get is a 12 x to the 3rd over x to the 4th, so that's a 12 times x to the negative 1. And then we have minus a 2x over x to the 4th, so that's a 2x to the negative 3. Okay, and then on the bottom, we have 3x to the 4th over x to the 4th, so that's just a 3. That's what I wanted. That's what I was aiming for. And then plus a 4x to the negative 1 and minus a 7x to the negative 4. Okay, so you might have been like, okay, well, why? How did we know how to do this? So basically, it wasn't just because the x to the 4th was the greatest degree on the bottom, but whenever you see, I was just trying to get it so that whenever you see an x value, we want to just remove all of the x values on the top. So you take the largest degree, you kind of spot that out, and then what you're going to do is divide by that greatest degree. Like if our greatest degree both on top or bottom, like if there was an x to the 5th on the top, then I'd try to probably try to divide by an x to the 5th or even an x to the 4th. So yeah. Anyways, continuing. Okay, so see here how now if we plug in an infinity of any sort, so we have 12 and then x to the negative 1, that's basically like a plus or minus infinity to the 1 power on the bottom, minus a 2 over plus or minus infinity to the 3rd on the bottom, and then we have a 3 plus 4 over plus or minus infinity, and then minus a 7 goes on top there, and then over a plus or minus infinity to the 4th on the bottom. Okay, so see how these terms, everything with an infinity on the bottom, that basically goes to 0. So this is a 0, that's a 0, so we have a 0 minus 0, then 3 plus 0 minus a 0. So what we're going to get is 0 over 3, which is equal to 0. Okay, which is not an indeterminate form. Okay.
Girl, I'm thinking that you're beautiful, and I can tell by your eyes that you feel me too. So why do you feel the way that you do? Why do you feel the way that you do?